I'm just going to talk to you today about balancing equations and why our students might not understand what we're doing with equations and our equal signs unless we actually build this idea. So here I have a balance beam. I have added sticky notes that have equal signs on them on the balance beam. On this balance beam, I already have a 10 on each side, which, oh, that was beautiful. There's a 10 here and a 10 here they've fallen down into our balance beam. And then I have one more. So this is 11 on both sides. And we can see balancing, the words balancing an equation are really great words, especially if we will go ahead and make balance beams and talk about that. If something is equal, no matter what happens to it, it will remain equal if it's what is done on both sides is equal. So here I have 11, the balance beam is equal. I can add one more to each side. It is still equal because 12 equals 12. It seems that this might be very obvious, but for students that don't create pictures in their minds as you're talking about balancing an equation or doing similar things to both sides of the equation, the point is we're keeping the equal. The only way we can say it's equal is that now it's 12 is equal to 12, and you have to play around with this a little further. You know, if I take away 2 from both sides, then what I have is 10. So it's in the use of real numbers that 10 does equal 10, that 13 does equal 13, and that I can take away 3 from both sides. It still equals 10 equals 10. And I can even multiply. I have 10 both sides. What if I multiplied times 2? If I multiplied times 2 only on one side, then I'm going to have 20 on one side. It will no longer be equal. We will have destroyed the equal sign. This is why when we multiply by 2, now we have 20, and we have maintained the equal. So until we can do this with real numbers, we can't solve for an unknown because we aren't understanding what's happening with this equal sign. So my next step in this is to go ahead and create this in student desks. I create the same thing with sorry about that, with a ruler. So under this ruler, I'm going to take this is my unknown here. So I'll have them also build with real numbers. 8 equals 8, 22 equals 22, have them build it. And so I have 2 10s right here as the middle part of the balance beam, and I create the balance here where we create what is even. And you'll see that if you have 2 blocks on this side, if you've got it in the center, then 2 blocks on this side at about the same distance apart will be balanced because 2 equals 2. So you can play with it a little bit. It seems maybe a waste of time, but in your 6th and 7th grade classes, it is important to at least have a moment where we talk about the equal. I take the equal from on here, I create it here to show that we're maintaining the equal, right? If a number is equal, then it's the same amount. And the beautiful things about these base 10 blocks is that their weight is similar too. So then I bring up the unknown. The unknown, of course, we tell them is any letter that is, what's our first unknown? I just put it an unknown. We don't know what's inside of there. So as soon as I bring up the unknown, I have to adjust my my little balance beam here, and I put the unknown very close here so it doesn't throw the weight. The box itself will throw the weight, so I can get it so that it's balanced with an unknown on there. So then I bring, this is the concept I bring up before I bring up algebra tiles, because you can build this with algebra tiles, but students can't know. They can memorize a rule like, well, if we do it to one side, we have to do the thing to the other side, or the change sides, change signs. Unless you build the show in a real tangible way, why you're changing sides and signs, then they're not understanding this. So, so here they are using a ruler, and I'm going to write down a problem. The problem is going to be 2x equals 8. Okay, it's important that as we do this 2x equals 8 here, it's important that we read it in a very specific way that doesn't interrupt our students with auditory processing struggles or their delays or in vocabulary. So I always say two somethings when you see the alphabet in there. Two somethings, 2 times something equal to 8. So the part that we know is the 8. So I will get 8 blocks out here and pile them right up here. Here, 8, 6, 7, 8. So now I have 8. And I might not be able to balance this. I know that my equal sign is there, so I know that it is balanced. So as now I have to say 2 somethings equal 8. Well, we know that that's a division problem because I'm going to say how many groups of 2 can I make inside of 8. So what happens is I'm looking here for those groups of 2, but I've got what's inside of here is that 2 groups there. So let me do a better one. This one was poorly done, but let me do a better one for you here. I didn't have the right amount of blocks ready for me. So the next one I'm going to do is called 4x is equal to 6. 4x, this is my 3x. Here's my 4x. Here's my 4x. I kind of wrote it on there, but you can't see with the dry erase very well. So again, I'm going to put it I'm going to try to make it so it does look balanced, but you can see it shorter on one side because I have my unknown. I don't know how many are inside of this box, this unknown box that is my x. Okay, so I've got 4x plus 6. So I have a group of something, 4 groups of something, whatever the something is, there's 4 of them and they're the same. And then I have 6 here. Okay, so I'm going to put my 6 right here. And what is that equal to? That is equal to 26. So I'm going to put my 26 in here. There's 20 and 6 more. Okay, so this is the way I would have all the students build it. I'd have them read it this way. 4 times something, 4 groups of one number plus 6 more is equal to 26. And we can kind of get this. The hard part is that kind of try to get it so it kind of evens out there. Okay, there we go. So we know they're equal. So then what we know is the 26. This is the thing we know. This is the unknown side. So this is where we begin saying, okay, if I didn't have this 6 in here, I would just get it down to making groups out of this, right? I'd be able to make groups out of the other part. So this is where if I take 6 away here, the only fair thing, if I really have this being even, is that I must take the 6 away from this side as well. Then I know everything will be even. Just like up here, when I was making this balance beam up here, when I made this, if I took away 10 from one side, I'd have to take 10 away from the other side because that's the definition of equal. So with this one down here, where we're working on with our ruler, that if I took 6 away from this side, I must take 6 away from this side. And then now I know that I can make 4 groups because this is 4 groups of something. If I can break this 20 here into 4 groups, then I will have my unknown solved. So if I take 20 and I count in 4s until I get how many 4s are inside of 20. That's pretty easy. 4, 8, 12, 16, 20. So inside of here, each one of those is 5. So I can open it up and I can see my groups of 5. I used blinking cubes on this one. I have 4 groups of 5. So it's the same as, in fact, you can take and line them on top of it to make sure that these 5 groups of 5 equal the same thing as 20. Okay, so for our very last one that I'm going to do today, I'm going to take 3x plus 2 equals 14. Now this time I'm going to do it with Matthew C blocks. So in the storeroom, there are Matthew C blocks. You can use them if you need to. It becomes a little bit easier because we're going to take this. This is my 3x here. Plus 2, it's a little easier because the 2 is considered one grouping of 2 here. So 3x plus 2 is equal to 14. So I'm going to use the Matthew C blocks in order to make the weight work the same way. Okay, is equal to 14. So here we have a balanced equation that whatever the groups are in this mystery box called x, they're all in groups of 3. So there's 3 of them. Now I've seen it done before where you've got 3 boxes and what's inside each box is the same, but it becomes very difficult to see that on a balance beam, so I don't do it that way. Instead, what's inside of here, well, we'll look what's inside of there. I've got groups of something, but the important part is that there's 3 groups of something plus 2 more equals 14. So I can see right away that the very difficult thing here is the addition of this little block right here, this little 2 right here. So if I take the 2 away, I'm going to be able to just make my groups, my 3 groups out of this. So I'm going to take this 2 away as well so that I know I've kept it even. The whole thing is to protect that equality, the equal sign. So now I can say, because I took 2 away from both sides, that both are still equal. So now I have, and I would have them write this underneath down here as well as I go, that I had 3x plus 2 is equal to 14. And then the next step I took was that, and I make them even in 6th grade, right? This is though it is algebra. I took away 2 from both sides. So now I have 12 and 3x. So 3x equals 12. So then when I get this open and can look inside of it, which I would do on my teacher's desk, I would say, well, how many 3s, how many groups of 3 groups can I make out of 12? Well, I've got them in here already. I've got 3 groups made to make it be equal. So let's figure that out. Here's a group of 4, another 4, and a last 4. So it turns into a division problem, and I would actually do the division problem on the paper here as well. I would say, well, if I divided both by 3 to find out how many 3s are inside of 12, then I would have my answer that there are 3 4s. And it's helpful to have this little group, this little block that is a 4. There are 3 4s inside of 12. So the answer is 4. So this is just the way I would build. I would use one whole period. And for students that forget to do the same thing on each side of the equal sign, they forget what the equal is and they have to build it. And this will help them so that they don't get into pre-algebra and algebra and keep trying to memorize patterns that don't make any sense to them, because this is the preliminary step of what we're doing on either side of the equal sign. The whole idea that you can add to both sides and subtract to both sides, which all teachers will say aloud, but students aren't understanding that it's just a simple balancing act. So that's all I have for you today, and thanks for joining me.